Numericals on symmetrical components. In this session, we'll solve some examples on drawing positive, negative, and zero sequence network for a given power system. Here, the data given for drawing the positive, negative, and zero sequence networks is given the network here, is given the network, and he will also give what is the rating of each component in terms of its MV and KV. Also, he will mention what are the its sequence components x1, x2, x0, x1, x2, x0 for the transformer, transmission line, as well as T2, that is the transformer T2, x1, x2, x0 will be given, and motor rating and the corresponding value of x1, x2, x0 all also given. For given data, then our object is to draw the positive, negative, and zero sequence networks. The first step in the drawing is, here it is for a demo purpose I am taking this first example without any the numerical values. The procedure is that you have to choose a common base quantities and convert all current value of the power system components on new base quantity or common base quantities. That is nothing but we have got this x1, x2, x0 of the generator is given on the basis of MVA kV. Now what you have to do is you have to choose the base MVA here and base kilovolts on any part of the circuit. You can choose kV. Correspondingly, the base MVA is remains same, that is a chosen value or it is a given value in the numerical, and the based on the transformer ratio, then you have to find out what is the base kilovolts here, that is base kilovolts here, and similarly here the base MVA is remains same, and the based on the transformation ratio you have to change the value of base kilovolts here. Then these x1, x2, x0 of all the components are transferred to a new value of per unit based on these new base quantities. Then accordingly you have to substitute or you have to mark in the positive, negative, and zero sequence network. Okay, just how you are assuming that now x1, x2, x0, x1, x2, x0 of all the components are transferred to a new base quantity, and we'll go ahead with how to draw the positive, negative, and zero sequence network for a given network here. Then I told you in the while discussing the theoretical aspect of the positive, negative, and zero sequence network, that is the source of voltage is existing in only the positive sequence network, that to generator and motor, and the transformer and the other component are the passive element in the system, they don't have possessing any source of voltage. Now I am start drawing the positive sequence network. Then the generator, that is the generator is represented by a source of voltage EA and the positive sequence, because we are concentrating on positive sequence network. Here we are drawing only the positive sequence network. Therefore what I am doing here is I am representing this generator by its positive sequence reactance x1G I will call, and there is a source of voltage of any one of the phase that I will take as E. Of course, first what you have to do, you have to draw the reference line. This is a reference line. Okay, this is generator. Then this generator is connected to bus number 1. Therefore, this is bus number 1. Here you have got a transformer. The next component is transformer between A and B. That is, it's already marked here. I will mark here. That is, here it is A and it is B. That is, between the point A and B, you have got a transformer. The transformer in the positive sequence network is represented by its positive sequence reactance. That is, it is X1 of T1. That is transformer T1 having X1 value. That is positive sequence, the reactance of the transformer 1. Then between B and C, you can observe here, between B and C, you have got a transmission line. Then you have to draw between B and C the positive reactance, positive sequence reactance of the transmission line. It is X1 of transmission line. X1 of transmission line. It is between C. Once again, between C and D, it is a transformer. Once again, it is represented by its positive sequence reactance. That is X1, it is of T2 transformer. Then this is your point T. Then we have got a bus number 2 here. It is a bus number 2. Of course, we have got a bus number 1 here. Okay, it is a bus number 1 here. That is 1 and is a 2 here. 2 here. Okay. Then from bus 2, the 3 motors they are connected. 3 motors are connected in parallel. That is, these are the remote end of the system. Therefore, this has to be connected to ground. Once again, the motor M1 is represented by source of voltage and its positive sequence reactance. M2 is also represented by its corresponding value of the EA and its X1. Similarly, the motor M3 is also represented by its source of voltage and its positive sequence reactance. They are connected in parallel. Therefore, first I will draw the motor M1. That is, motor M1 is represented by its positive sequence reactance and its the voltage. I will call EM1, that is connected to reference. This is X1 of motor 1. Then second, I will draw here the second motor from the same bus, and I have got a reactance and a source of voltage for the second motor. This is your EM2 and it is X1 of M2. Then similarly, I will draw a third one, that is its reactance of the third and its source of voltage. This is EM3, it is X1 of motor 3. It is very simple. Only the generator is represented by source of voltage and its positive sequence reactance, whereas the motors are represented by source of voltage and their corresponding positive sequence, the reactances here. Then the transformers and the transmission lines are replaced by their positive sequence, the reactance. This is how we have to draw the positive sequence network for the given network. Then we'll move on to the negative sequence diagram. Negative sequence diagram here. Now, in the negative sequence diagram, neither generator nor transformer or transmission line having the source of voltage. In the negative sequence diagram, all the components are represented by their corresponding value of negative sequence reactance. Therefore, first what you have to do is, first you have to draw the reference line. Then first I will draw for a generator. Generator is represented by its positive negative sequence reactance. That is, it is X2 of the generator. Then there is a point A here and B. Between AB there is a transformer. The transformer is represented in negative sequence is by its negative sequence reactance of T1. Next, between B and C, you have got a transmission line. The transmission line is represented by its negative sequence reactance X2 of TL. Then between C and D, once again you have got a transformer that is represented by its negative sequence reactance, that is X2 of T2. Then from D we have got the bus 2, that is a common bus 2, to which the three motors they are connected. Three motors they are connected in parallel. Therefore, the first motor 1 can be represented by its negative sequence reactance, that is it is X2 of M1. The next one is it is X2 of the motor 2. It is X2 of motor 2. Then the third I will draw as it is X2, it is of the motor 3. That is, the negative sequence diagram is very simple. Here there is no involvement of any source of voltage, means each components are represented by the negative sequence reactances, that is transformer, transmission line, transformer, the motors, all these three are connected in the parallel. This is how we have to draw the negative sequence diagram for the given network. Then we'll move on to the zero sequence network for a given network. That is what we have drawn here is positive sequence network, then negative sequence network, then you have to draw the zero sequence network. Okay, in the zero sequence network, the only thing is that the very important factor is how to draw the zero sequence network for the different connected transformer. Therefore, for the ready reference, just I will put a reference network here at the corner here. Just I will make it here. That is, if it is from P to Q that you are discussed, between P to Q, that is from primary to secondary. For example, here from A to B, or you can call C to D in this case. That is nothing but P and Q here. Then how we are representing that? That is, you are making use of the concept of the switches here. That is, there are two switches here. Okay, then this is another two switches here. Okay, this is reference line. Okay, that is, we know that that is, this is, you are represented as A, B switches. These are C and D switches. That is what you are done. But one thing is that the first thing is that while drawing the zero sequence network, draw the reference line first. First draw the reference line. Reference line. Then the first element in the network is the generator. The generator is grounded. Therefore, there is a path to the ground. There is a path to the ground because it is grounded here. Therefore, the generator is represented by its zero sequence reactance. As such, there is no Xn here. Xn is not given. Only the zero sequence reactance of the generator is there. Therefore, there is a path to the ground here because it is grounded. Therefore, what you have to do is you have to draw the generator with its zero sequence reactance that you have to draw to the ground. That is, it is X0 of generator. Okay, because it is connected to ground, because it is grounded here. Then we will go to the point A and B of the transformer. This is very, very important here. Here it is, the primary is connected to delta, secondary is connected to star, that too the secondary is grounded. If the secondary is grounded, means it is closed, then to the Q this reactance is connected, whereas D is open. Because it is star connected. Already you are making use of the switch A here, your switch B, because the secondary is star connected grounded, therefore you have to close this, and the primary is delta, therefore you have to close this. That is, this is closed, this is closed. Therefore there is a connection from Q to Z0 or X0, that too goes to ground, and to primary side it is open. Therefore the same concept I am showing here, that is towards A, that is towards P, it is open. Towards Q it is closed, that is B is closed. And in the primary side, that is, it is a delta connected, this switch is closed, therefore you have to draw here this network. That is a representation of star delta transformer. That is a representation of delta star grounded transformer. Then between B and C we don't have any problem, because it is a transmission line that is represented by, it is zero sequence reactance. It is X0 of T1. It is X0 of transmission line. This is point C. Between C and D, you have got star delta. It is a star delta. Star delta means that two grounded. Means switch A is closed, switch D is closed. Means from C to Z0, and it is grounded here. Like this, you are getting a network like this. Okay, therefore that is, you have to draw, that is from C there is a Z0 and switch is closed here, that is D, because secondary is delta connection, and this is open here, it is open. That is a point D. Then point D is connected to bus here, bus 2. That is, it is bus 2. Here you have got a bus 1. Okay, here you have got a bus 1. Then for this bus 2, we have got 3 motors. Just you have to look into the motor connections. Then accordingly you have to draw the zero sequence network for M1, M2, M3. First I will take M1. Here M1 is grounded. Therefore from the bus number 2, there is a path for the ground. And similarly, if you are look into here, M3, it is also grounded. It has got a path here. But here it is not grounded. The M2 is not grounded. Therefore, there is a break in zero sequence network to the ground. That you have to keep in your mind while drawing the zero sequence network very carefully. First, I will draw for motor M1 here. It is grounded. It is X0 of M1. Then I will write for the M2 which is not grounded. Therefore just what I am doing here is I am drawing here X0, then I am keeping isolation here. It is open because there is no path for zero sequence current to flow. Therefore you have to keep it open. It is for M2. Then if you go for the M3, it is once again it is grounded. Therefore there is a complete path for a zero sequence current. Therefore I will draw this to ground. This is X0 of M3. This is how we have to draw the negative sequence network for a given network. Okay, this is how we have to practice. Then in the next session, once again, we'll solve some more numerical on positive, negative and zero sequence network.